Playing God: The History and Ethics of Genetic Manipulation. Imagine this. Scientists now have the power to rewrite the DNA that defines us. With technologies like CRISPR, diseases that were once incurable can potentially be eradicated, and parents can choose the traits of their unborn children. But with this power comes a critical question. Should we do it? A recent study shows that over 60% of people support genetic editing to cure diseases. But when it comes to designing traits like intelligence or appearance, support drops sharply. Are we playing God, or simply playing catch-up with evolution? Genetic manipulation has long been the subject of fascination and fear. It feels like something out of science fiction, altering the genetic code to reshape life itself. But it's not fiction anymore. It's real, it's happening, and it's reshaping medicine, agriculture, and ethics in profound ways. The potential of genetic manipulation is staggering. Imagine a world where genetic diseases like sickle cell anemia, Huntington's disease, or cystic fibrosis are eliminated forever. Imagine crops that are resistant to drought, pests, and disease, feeding billions without the need for harmful chemicals. It sounds like a utopia, doesn't it? But the journey to get here hasn't been without controversy. From fears of designer babies to questions of inequality and unintended consequences, the ethics of genetic manipulation are as complex as the science itself. So how did we get here? What are the risks? And where do we draw the line between innovation and hubris? The promise of genetic manipulation is matched only by its challenges. Perhaps the most profound is the philosophical question of whether humanity should wield this power at all. Critics argue that tampering with the genetic code, often described as the blueprint of life, is an act of playing God, an intrusion into territory best left untouched. And it's not just a spiritual argument. The ethical dilemmas are vast. If we can design the perfect baby, free from disease, with enhanced intelligence, athletic ability, or even specific physical traits, what happens to the concept of individuality? Will we create a world where genetic perfection becomes the standard, leaving those without access to such technology behind? This leads to another major concern: inequality. Genetic manipulation, especially for enhancements, is likely to be expensive. If only the wealthy can afford to edit their genes, or those of their children, are we creating a new class divide? A genetic elite versus everyone else? Then there are the unintended consequences. Evolution is a slow, deliberate process, one that has shaped life over billions of years. By editing genes, we risk unforeseen ripple effects. A gene edited to eliminate one disease might inadvertently increase the risk of another. And once a gene is altered, the change is permanent, passed on to future generations. One of the most groundbreaking tools in genetic manipulation is CRISPR, a technology that allows scientists to cut and paste DNA with remarkable precision. Since its development, CRISPR has been used to edit the genes of plants, animals, and even human embryos. In 2018, a Chinese scientist claimed to have created the first genetically edited babies, twin girls whose DNA was altered to make them resistant to HIV. The announcement sparked outrage. While the scientific community condemned the experiment as reckless, it highlighted just how close we are to a future where editing human genes is commonplace. Take the idea of designer babies. At its most basic level, genetic editing could prevent life-threatening diseases. But it's not a stretch to imagine parents wanting to choose traits like height, eye color, or even talents. Is this a slippery slope toward a dystopian world where humans are engineered for specific purposes? Yet, the potential benefits are undeniable. Genetic manipulation could eradicate diseases that have plagued humanity for centuries. Scientists are already working on editing genes to cure sickle cell anemia and certain forms of cancer. Crops genetically modified to withstand harsh climates could combat global hunger. Even animals, like genetically modified mosquitoes, could help reduce the spread of diseases like malaria. But as promising as these developments are, Opposing viewpoints remind us of the risks. Critics argue that the long-term effects of genetic editing are still unknown. What happens when edited genes interact with natural ones over generations? Could we inadvertently create new diseases or environmental imbalances? One of the most pivotal moments in the history of genetic manipulation occurred in 2018, when the world learned of the genetically edited twins in China. For many, this was a wake-up call, showcasing just how quickly science had outpaced ethical oversight. The experiment violated numerous ethical standards, including the lack of proper consent and transparency. But it also raised a question that still haunts us. If we can edit the genes of humans, who gets to decide when, how, and why it's done? This moment forced scientists, ethicists, and governments to confront the need for stricter guidelines and global cooperation. The potential of genetic manipulation is immense, but so is the potential for misuse. The line between curing diseases and creating designer humans is razor thin, and crossing it could change the fabric of society forever. Genetic manipulation sits at the intersection of possibility and peril. On one hand, it promises to cure diseases, feed billions, and push humanity to new heights. On the other, it challenges our understanding of ethics, identity, and what it means to be human. As we stand on the precipice of this new frontier, it's crucial to remember the lessons of the past. Science without ethics is a dangerous game, and the decisions we make today will shape the world of tomorrow. Whether genetic manipulation becomes our greatest achievement or our gravest mistake will depend not just on what we can do, but on what we should do. What are your thoughts on genetic manipulation? Is it the key to humanity's future, or are we playing with fire? Share your thoughts in the comments. Let's keep the conversation going as we explore the boundaries of science and humanity together.